Hello all. Today I am going to announce the answers for part 6. Just check the answers whether the answers are correct or not. Today we are going to see about 7th video. In 7th video we are going to discuss about modulus of a complex number. So till date we learnt about complex number, and in complex number you learnt real part, imaginary part, and real part and imaginary parts are the real numbers, and how to add, subtract, multiply and divide the complex numbers. Then we learn what is the conjugate of a complex number. Now we are going to study about modulus of a complex number. So let us take let z is equal to x plus iy. Let z is equal to x plus iy be any complex number. I want to find out the modulus of this complex number z. How to find out the modulus of the complex number? I am going to deal it in a different way. If z is equal to x plus iy, I am writing modulus of z. Modulus of the complex number, that is modulus of z is root of real part square plus imaginary part square. Here iy is the imaginary number and x plus iy is the complex number. X and y are real, x and y are real numbers. Y is the imaginary part of z. X is the real part of z. So now I am going to write modulus of z is root of x square plus y square. How I am getting modulus of z? What is the meaning of modulus of z? Modulus of z is nothing but just like a real line. In real line, if you have a point 2, 3 means, what is modulus means? We are going to find out the distance of this point from the origin. Is it clear all of you? Distance of the point from the origin. So let us take z is equal to x plus iy. 2 plus 3i. Now we are interested in finding out modulus of z. Already I told that modulus of z is root of x square plus y square. How we are getting? So modulus of z is nothing but a distance of z from the origin. Once again I am repeating you. Modulus of z is nothing but distance of z from the origin. So I want to find out the distance of this complex number from the origin. Suppose it is 2, 3 means I am going to draw the perpendicular, and this is a right angle triangle. So this distance is 2 and this distance is 3. So the hypotenuse is nothing but the modulus of z of this. Hypotenuse, how will you find out hypotenuse? Root of 2 square like real number system plus 3 square, which is equal to root of 4 plus 9, which is equal to root of 13. So the complex number, that is if I am taking it as a means, the value of OA is root 13. Similarly, I am going to take a complex plane. In a complex plane, this is real part, this is imaginary. So real axis, this is imaginary axis. Consider a point x plus iy or z. So z is nothing but x plus iy. Already I told you. So I want to find out the distance of this point. Let it be the point is a. I want to find out a. So this is nothing but this distance is x and this distance is y. What do you think about this distance OA? OA equal to root of x square plus y square. This OA is nothing but our modulus of z is equal to root of x square plus y square. Is it clear all of you? So modulus of z is nothing but the distance of z from the origin, or distance of any complex number from the origin. Is it clear? Okay. Now we want to discuss about some more results in modulus of z. Already you know that if z is equal to x plus iy, result 1. We are going to deal about some results. Result 1, if z is equal to x plus iy. Already you know that what is z bar? Z bar is equal to x minus iy. Now what will you get z into z bar? Just multiply these two. This is a plus b and this is of the form a minus b. A plus b into a minus b is a square minus b square. X square minus iy the whole square, which is equal to x square. I square is minus 1, minus into minus plus x square plus y square. Just to see the relation of modulus of z is equal to root of x square plus y square, and z bar is equal to x square plus y square. So we can relate these two. How can we relate these two? Z into z bar is nothing but, see here, x square plus y square. On squaring you will get the answer. So modulus of z square. So we are coming to know one more result. Z into z bar equal to modulus of z square. So please concentrate, then only you can understand this full part. Modulus of z is equal to root of x square plus y square. If z is equal to x plus iy, z bar is equal to x minus iy. So once again I am repeating you have to come across many symbols. So don't forget all these symbols. Listen here, if z is equal to x plus iy, I am repeating all the result. Minus z means changing both the signs of real and imaginary part. Minus x minus iy. See here, z minus z. And z bar. The meaning of z bar is we are changing the sign of the imaginary part alone. That is x, imaginary part is y, minus iy. Now we have seen the modulus of z. See the symbol minus z, z bar, modulus of z. Modulus of z is nothing but root of x square plus y square. Okay. Now we see the symbol z bar, z power minus 1. So you should not confuse all these symbols. If z is equal to x plus iy, minus z is equal to minus x minus iy, z bar is equal to x minus iy, modulus of z is equal to root of x square plus y square, and see that modulus of z is always a real number. See here, this is only a real number, there is no I here. Z power minus 1, which is nothing but 1 by z. 1 by z is nothing but 1 by x plus iy. How we are getting 1 by x plus iy? We are multiplying and dividing the numerator and denominator by its conjugate. So what will you get? X minus iy by multiplying these two, x square plus y square. You clearly understand. Is it clear now? So these, you should not forget these notations. All the notations are entirely different. Please check it out. See here, this is the geometrical representation of modulus of z. So the length OA represents modulus of z. Okay. From this diagram we noted that x is the real part and y is the imaginary part. See here, in a triangle, I am coming to geometrical part. In a triangle, hypotenuse is always greater than the other two sides. So we can say that x modulus of z is always greater than or equal to x. What is the meaning of x? Modulus of z is greater than or equal to real part of z. Or I can simply say that real part of z is lesser than or equal to modulus of z. Similarly, see from this diagram, modulus of z is greater than or equal to y. So modulus of z is greater than or equal to y means modulus of z is greater than or equal to imaginary part of z. Is it clear now? Or I can simply say it as imaginary part of z is lesser than or equal to modulus of z. So see, just to see what are all the results are used in many problems. So check it out. Real part of z is lesser than or equal to modulus of z. Imaginary part of z is lesser than or equal to modulus of z. And z into z bar is equal to modulus of z square. Is it clear now? So we have learned these three properties now. Next we are going to see one more property. Modulus of, what do you think about modulus of z bar? I want to find out modulus of z bar. Already you know that modulus of, what is z bar? X minus iy. How to find out modulus of z? Just take the real part square and the imaginary part square, then add those two. So root of x square plus y square. This is nothing but modulus of z. So we are coming to know that modulus of z is equal to modulus of z bar. This is one more result. Okay. So this is the first result, and this is the second result, and this is the third result, and this one is the modulus of z is equal to modulus of z bar. Let us take this as the fourth result. Is it clear, all of you? Next one, let us we are interested in finding out what is the relationship between modulus of minus z and modulus of z. Take it as the fifth result. Modulus of minus z, because already I explained you all the notations. Modulus of minus z. How would you write modulus of minus z? Modulus of minus x minus iy. Okay. How to find out modulus? Root of real part square plus imaginary part square. Clear? X square, root of x square plus y square. So again it is modulus of z. So from this we are knowing that modulus of z bar equal to modulus of minus z equal to modulus of z. Is it clear now? Okay. Next we are going to discuss about an important property, which is triangle law of inequality. We are going to discuss about triangle law of inequality. So what is triangle? I will prove this result in two ways. That is modulus of z1 plus z2. Be careful. Lesser than or equal to modulus of z1 plus modulus of z2. Is it clear? Modulus of z1 plus z2 is lesser than or equal to modulus of z1 plus modulus of z2. In conjugate, it is entirely different. I will once again I will tell you about the conjugate. Don't confuse with the conjugate and modulus. Conjugate is entirely different from modulus. Check these two. Okay. Modulus of z1 plus z2 is lesser or equal to modulus of z1 plus modulus of z2. I have to prove the result. This result is very, very important. Okay. How to prove this result? Let us take modulus of z1 plus z2 square. How to find out modulus of z1 plus z2 square? Just I am going to apply this concept. Modulus of z square equal to z into z bar. Clear now? If you are having modulus of z, inside the modulus, if you are having z means, we are going to take z and its conjugate. So inside the modulus, what you are having here? z1 plus z2. So I am going to take this z1 plus z2 inside the modulus z1 plus z2 into that's conjugate z1 plus z2 bar. Is it clear now? So modulus of z square is equal to z bar. Similarly, I am going to write this as z1 plus z2 into z1 plus z2 the whole bar. Already you know the result in conjugate. z1 plus z2 into what is conjugate of sum of two complex numbers? Conjugate of the first complex number plus conjugate of the second complex number. Is it clear? Okay. Next, just multiplication I am going to multiply. z1 into z1 bar plus z1 into z2 bar plus z2 into z1 bar plus z2 into z2 bar. Is it clear, all of you? So just I am multiplying z1 z, or you can multiply from this side, that side, anything. z1 z1 bar, z1 z2 bar, addition, z2 z1 bar, z2 z2 bar. Is it clear? So now come again using this result. What is z into z bar? Reverse of the property. Here the square becomes a complex number and its conjugate. A complex number and its conjugate, I am taking it in the reverse sense. A complex number and its conjugate becomes modulus of that complex number square. See here, here z1. Again also z1, but its conjugate. And complex number with its conjugate gives the modulus of what complex number we are taking here? z1 square. Is it clear now? Now coming to this part. z2, z2 bar. The same method. Modulus of z2 square. Is it clear? Plus, I am writing the second one as it is. z1, z2 bar. See here, I want to give you one result in conjugate. You know that, I am writing it here. You know that z bar, already it is a conjugate. Conjugate of a conjugate equal to z. You know this result. I am going to apply this result here. Okay. So modulus of z1 square plus z1 z2 bar, I am writing this one. Instead of writing this, I am going to write it as the same term z1 z2 bar the whole bar. Is it clear? z1 bar, we are getting z1 bar. This conjugate, I can write z2 z1 bar as z1 z2 bars conjugate. Clear now? Okay. Next we are going to discuss about modulus of z1 square. How I am simplifying, just to check it out. I am bringing this part here, modulus of z2 square plus, this is one complex number, z1 z2 bar, plus the same complex number is here with its conjugate. The same complex number is here with this conjugate. Again I am applying the conjugate property. What is the conjugate property says? If you have a complex number z and I am going to add the complex number with its conjugate. Add the complex number with this conjugate. Here is z, conjugate is here. Just add these two results. So I am explaining, already I am explaining these parts. X plus iy, x minus iy. While adding these two, iy get cancelled. You are getting 2 times x. 2 times x means, so x is equal to by 2. Is it clear? So x is nothing but real part of z. So I am combining these two. And I am combining these two and I am going to write it as, this is nothing but z plus z bar by 2 is x, or z plus z bar is 2x. Is it clear all of you? So z plus z bar is 2, x is nothing but real part of z. So I am writing it as 2, real part of z is, we are writing it as z. Here the real part of what? z1, z2 bar. Is it clear all of you? Okay. Okay. See here, 2 times real part of z1 z2 bar. I am using this concept. What is the concept? Real part of z is lesser than or equal to modulus of z. If z is z, you are writing it as modulus of z. So I can write this as modulus of z1 square plus modulus of z2 square plus 2 times real part of this. Real part of this can be represented as modulus. So modulus of z1 z2 bar. Is it clear now? But we have to use the symbol lesser than or equal, not equal. So I am going to use lesser than or equal. See here, I am going to use lesser than or equal to. This is very important. Okay. See, again I am going to split the part. Lesser than or equal to modulus of z1 square plus modulus of z2 square plus, I will explain it later. Anyway, I have to explain this in 2 ways, but I will explain this later. So modulus of z1 into z2 bar square is nothing but 2 times modulus of z1 into modulus of z2 bar. Okay, which is equal to, this part is lesser than or equal to this, but these two parts are equal. Automatically you will use the symbol lesser than or equal to. You should not use the symbol lesser than or equal to. You have to use the symbol equal to. Okay. Just to see, this is, I am writing this as it is, plus I am writing this as it is, plus I am taking this as it is, and I am taking this as it is. Instead of modulus of z2 bar, see this result? Modulus of z and modulus of z bar are one and the same. So I am applying the same concept, modulus of z2. Is it okay? It looks like a form of a square plus b square plus 2ab. So simply I can write it as modulus of z1 plus modulus of z2 the whole square. Clear now? So what you are getting? Modulus of z1 plus z2 the whole square lesser than or equal to modulus of z1 plus modulus of z2 the whole square. From this what we are getting? Therefore, modulus of z1 plus z2 is lesser than or equal to modulus of z1 plus modulus of z2. Is it clear? So this property is called as triangle law of inequality. So I will represent it geometrically. Geometrical representation. Geometrical representation. How to represent it geometrically? Now I am going to take the real axis imaginary axis, and I am going to take z1 here and z2 here. Already you know that where z1 plus z2 will fall. z2 is here. Here is z1 plus z2. So consider this is a vector, this is a vector. This point P is nothing but, so this length is distance of the complex number A from origin is modulus of z1. Already I explained. This is modulus of z2. Therefore this is modulus of z1 plus z2. Is it clear? Now I am going to complete this parallelogram. So if this is modulus of z2 means automatically the length is also modulus of z2. So by triangle law of inequality, just see the triangle. Already you know that in triangle inequality, modulus of z1 plus z2, this side is always lesser than sum of the other two sides. So from diagram itself we can prove that modulus of z1 plus z2 is lesser than or equal to modulus of z1 plus modulus of z2. Is it clear now? Now what is the answer for modulus of z1 minus z2? Can anybody tell this answer? Modulus of z1 minus z2 can be represented as equal to modulus of z1 plus minus z2. Is it correct or not? Which is equal to modulus of, which is lesser than or equal to, which is lesser than or equal to modulus of z1 plus modulus of minus z2. Already I told you modulus of z1 plus modulus of z2, because modulus of minus z is equal to modulus of z. Already I explained this concept. Modulus of minus z is equal to modulus of z. So modulus of minus z2 is modulus of z2. So from this we are coming to the conclusion that modulus of z1 minus z2 is lesser than or equal to modulus of z1 plus modulus of z2. So I think your doubt is clear. You have come across the sixth property, modulus of z1 plus z2 lesser than or equal to modulus of z1 plus modulus of z2. Then we have seen this property also, modulus of z1 minus z2 is lesser than or equal to modulus of z1 plus modulus of z2. Okay, next this is let us take this property as the seventh one. Now we are coming to the eighth one, how to find out modulus of z1 z2. How to find out modulus of z1 z2? According modulus of z1 z2 is, I can write this as, or I have to prove modulus of z1 z2 equal to modulus of z1 into modulus of z2. Let me prove this. Modulus of z1 z2 equal to modulus of z1 into modulus of z2. How to prove this result? Let us take as same as this procedure. As same as this procedure I am proceeding. z1 z2 modulus square. Okay. So modulus square, modulus of z square is equal to z bar. I am using the same concept. So z1 z2 inside is z1 z2 into that bar into z1 z2 the whole bar. Clear now? z1 z2, first what is inside? Inside is z1 z2 into that bar, z1 z2 bar. So just I am going to multiply all these things. So z1 bar into z2 bar. Be careful, I am not multiplying, I am not applying the distributive property. All are in multiplication. All multiplication means you have to use the associative property. So I am using the associative property. Z2, or I can write this as one more step I will do. z1 z2 into z1 bar into z2 bar. Already you come across in conjugate. Conjugate of product of two complex numbers equal to product of conjugate of two complex numbers. I am applying the result. Just I am shuffling or rearranging. Okay. z1 bar. Already I explained. z1 bar equal to modulus of z1 square. See here. into Z2 Z2 bar equal to modulus of Z2 square. So modulus of Z1 Z2 equal to, here also square, here also square. So modulus of Z1 Z2 equal to modulus of Z1 into modulus of Z2. See, like conjugate, what we are doing, modulus of product of two complex numbers equal to product of the two modulus. The same concept is applicable for conjugate. Conjugate of product of two complex numbers equal to product of the conjugates. But it is not applicable for your addition. Addition of modulus of two complex numbers is not equal to, but it is lesser than or equal to modulus of Z1 plus modulus of Z2. Don't confuse these two. Okay, you can do this on your own. Z1 by Z2 modulus equal to modulus of Z1 by modulus of Z2. You can check it by yourself. Is it clear now? So we come across this 9th property. Now we want to see the extension of 8th property. Extension 8th. So modulus of Z1, Z2, Z3, etc. Zn can be represented as modulus of Z1 into modulus of Z2 into modulus of Z3, etc. modulus of Zn. Here all the Z1, Z2, Z3 are different, we are multiplying. Suppose if all these are equal, modulus of Z into Z into Z into etc. n times. I can write this as modulus of Z power n equal to, we will get modulus of Z into modulus of Z into modulus of Z etc. n times. So you get modulus of Z n times. Okay, this is the first result. 8th result 1. This is our second result. Is it clear all of you? So modulus of Z power n is equal to modulus of Z the whole power n. Okay, now coming to modulus of result 3 using the above properties. Modulus of Z1 plus Z2 is lesser than or equal to modulus of Z1 plus modulus of Z2. Already you know from this diagram as well as a proof. But this modulus of Z1 plus Z2 is greater than or equal to. Addition, this is lesser than the addition, but you also know that it is greater than the subtraction. Modulus of Z1 minus modulus of Z2. But you will get a doubt. If this difference becomes positive or negative, because modulus is always positive. If this difference is positive, it is okay. Suppose if this difference is negative, I am going to apply modulus. This is very useful to find out the upper bound as well as the lower bound. This can also simply be written as modulus of Z1 minus Z2, or you can say this proof also. Can you guess? I will tell you, modulus of Z1 plus modulus of Z2. This is greater than or equal to modulus of Z1 minus modulus of Z2. We will do many problems using this model. Is it clear? So please thorough all these properties before entering into the next concept. The last concept is distance between the last one in modulus, distance between two complex numbers. See here, in first we have seen that the distance of a complex number from the origin only. See here, we are finding the distance of a complex number from the origin. Here we are going to find out the distance between two complex numbers. Okay, now let us take letter Z1 is equal to x plus iy, Z2 equal to x1 plus iy1, Z2 equal to x2 plus iy2. Now I want to find out the distance between distance means we are going to find out the modulus. So now I am interested in finding out modulus of Z1 minus Z2. Like number system I am doing. Modulus of how to subtract these two complex numbers, subtracting the real part and subtracting the imaginary part, and I am writing the imaginary number. So x1 minus x2, listen carefully, plus I into subtracting the imaginary part y1 minus y2. Here it is bracket, be careful, and it is modulus here. So what is the meaning of modulus? Squaring the real part and squaring the imaginary part, taking the square root. So root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Already you know this concept. This is nothing but distance between any two points x1 y1 and x2 y2. See here, already you learnt in 10th standard. There is a point x1 y1 here, there is a point x2 y2. A of x1 y1 let it be, and b of x2 y2. So the distance between these two points is x2 minus x1 the whole square plus y2 minus y1 the whole square, or x1 minus x2 the whole square, y1 minus, it is as it is same. So in order to find out the distance between two complex numbers, it is enough to subtract the complex number, then find its modulus. Is it clear now? Okay. Let me find out some results. We are interested in finding out the distance between A of z1 is equal to 2 plus 3i and z2 equal to minus 2 plus 3i. What is the distance between two complex numbers? How would you find out? Distance is nothing but modulus of z1 minus modulus of z1 minus z2 equal to modulus of 2 minus of minus 2. Just see here, z1 is this, z2 is this, subtracting the real part. 2 minus of minus 2. So 2 minus of minus 2 plus I into 3 minus 3, which is equal to modulus of 2 plus 2 4 plus 3 minus 3 0 0i. Modulus of 4 minus 0 is root of 4 square plus 0 square, which is equal to root of 4 square equal to 4. So see here, which is nothing but modulus of 4. Modulus of 4 is 4. Clear now? So what is modulus of I? Can you guess? Modulus of I is equal to root of 1, which is equal to 1. What is modulus of 3 plus 4i, which is equal to root of 3 square plus 4 square, which is equal to root of 9 plus 16 root 25 equal to 5. Clear now? So in this section you have seen the modulus of the complex numbers. In modulus of the complex numbers, we have seen many properties. Please go through all the properties, then only you can easy to do all the problems. Please thorough these properties, and there is no exercise today. You have to thorough all the properties before entering seeing into next video. If you are thorough with the properties, means you can do any problem. So kindly do it. Thank you.